Okay, so in this video, we're going to take a look at deriving the natural logarithm of x. And once again, if you've seen my exponential video on deriving exponential functions, I mentioned that there's a chain rule in that, and this occurs also with ln of x. So if I use my little box here to show the demo, if I have f of x is equal to ln x in this case, if I derive this, okay, and I call this inside here my argument a block, all right, what we need to make sure we do is, if you look at this, we have the derivative of ln of x is 1 over x. Well, it's actually 1 over x, but we have to chain on to the derivative of this x in here. But of course, the derivative of x is just 1, so that gives us 1 over x. So when we have a ln, we must think about it this way here. I have ln, and then maybe I have some function of x inside here, g of x. All right, and whenever we derive this, easiest to think of it as this. Here's my derivative. Here's my derivative. The derivative of this is 1 over whatever is inside my block, so I don't touch that. And I chain that onto the derivative of my block here. So that's how we do ln. So let's take a few demo examples here. This is from 12F in the Hayes book. So we have ln of 7x, so I'll just even block this out so we can see. Here's my block, block, and inside here is block. So if I take the ln of 7x and I derive it, I am going to get, in this case, 1 over the block times by the derivative of 7x, and that's just 7. And of course these cancel, so you end up with a simplified derivative, which is 1 over x. Okay, let's try the second one. So it says if I derive a ln, it's 1 over the ln, and I have to chain that onto the derivative of what's inside here, and the derivative of 2x is 2, and the derivative of 1 is 0. So if you clean this up a bit, you're going to have 2 over 2x plus 1. So there we go. That's our derivative in this case. Let's take a look at the next one. Deriving again, we're going to have 1 over the block, and that's going to be chained onto the derivative of the block, so I'm going to derive this. So derivative of x is 1, and if I derive 2x squared, I will get 2x. And then we can rewrite this as 1 minus 2x all over top of x minus x squared. So there's my derivative for my third one. Now for my fourth here, we can derive this. If you derive 3, it goes to 0, so that's not going to bother us. If there's a constant in front of the log, we just keep that constant in front. And now if I derive just ln of x, we have 1 over x. So that's going to be multiplied by that. So in the end, we're going to have it as negative 2 over x. And that's my derivative for the log. So these 4 are simple chain rule lns that we are deriving. Now below, we have some more advanced ones, and these require you to use such ln rules as if I have ln of a times b, I can write them as ln of a plus ln of b. So that's one log rule. Our second ln rule is a over b, and we have that on our formula booklet, which is ln a minus ln of b. And our third ln is if we have something like x to the n, we can bring the n out in front, so we have n log of x here. All right. If you want, you can put your brackets just to make sure that you know what part of the argument is in the ln. So these three rules here we have to know for these next three questions. So if we look at this here, the first thing I'm going to do is I'm going to clean this up so I don't have this square root house. So I'm going to have 1 minus 2x, like so. And then I'll call this rule number 1, rule number 2, and rule number 3. I'm going to use rule number 3 here, so I'm going to bring the 1/2 out in front. So I have yet to derive yet. All I've done is clean this up. And now what I'm going to do is derive. So here is my derivative. Okay, so I have this. So if I derive 1/2 ln, now I leave that 1/2 in front, it's just a constant. And if I derive this, we have 1 over this block here. And then we have to, of course, chain that on here. So if I chain the derivative of 1 minus 2x, the only thing that we're going to have the derivative of is a -2 from this bit here. The 1 will go away because that's 0. And then, of course, when you start cleaning this up, this 2 will cancel, and this negative will come in front, and you should end up with -1 over 1 minus 2x. So there's your final answer, a little bit more cleaned up. All right. Let's take these down here and work with them down here. So in this example here, what I'd like to do is, first of all, bring this 2x plus 3 up top. So if you know your indice rules, you should be able to write this here as to the -1. So I brought this whole thing and I flipped it up here. And now I have this ln 2x minus 3 to the -1. An alternative method is to use rule number 2 and split the logs between ln 1 minus ln of 2x plus 3. That might be easier, but you'll get the same answer. From here, I bring the minus out in front. So I have y is equal to negative ln of 2x minus 3. And then now we're ready to take the derivative. And if we take the derivative, we're going to have -1 over 2x minus 3. And of course, we have to chain that onto the derivative of our argument of the ln. And the derivative of 2x is 2. And the derivative of -3 is gone. So this 2 is going to multiply the 1 on the top. And you can clean that up a little bit, but that should be the end of it. There should be no way of simplifying it anymore. Now our last one here, what we have is we have a times b, so we're going to use number 1 in this case. So the first thing I'm going to do is split this apart, like so, plus ln of square root x, but I'm going to write this as x to the 1/2 because we're going to need that anyways here. All right. And now actually you can see if I bring this x out in front, the ln of e is 1, so we have just x there. If I bring the 1/2 out in front there, I'm going to have 1/2 of ln of x. And now I can take my derivative and it's much easier to do. So the derivative of x is 1, so that's fairly straightforward. And if I derive 1/2 ln x, I keep the 1/2 as is. And the derivative of ln x is 1 over x. So if we clean this up, finally, we have 1 plus 1 over 2x. So there you go. That's our derivative for this product rule here. So there you go. That's how we go about deriving lns. Now remember, there's a block and we always have to chain the derivative of our block here, like I mentioned here in the red box.